Hi students, today we will discuss direct memory access, also called DMA, and we will also discuss how DMA operated in our system. Let's go to our diagram. Here is a CPU, and here is your DMA controller, and here is your main memory, and here is your IO devices. First you have to notice IO device and main memory. Okay, these are important things in our DMA because the data transfers may mostly taken in IO device and memory, or IO devices and other devices. IO devices may be memory, or IO devices to CPU. Okay, let's move towards it. First of all, we have to first make sure that there can be a single DMA for all our IO devices, or there may be a universal DMA controller for all our IO devices. First of all, or there may be in later generation of systems, each IO devices have their dedicated DMA controller. Okay, you have to first notice two things, that there may be a universal controller for every IO devices, or there may be every IO device have their dedicated DMA controller. Okay, first of all you have to notice that. Then let's move how this works. Okay, first of all, CPU generates a request that maybe there is a transfer between IO devices to main memory. Okay, CPU give the command, then the DMA get the command. Okay, then first make sure there is the device which takes place in the transfer, and connect the main memory, and main memory is also present. Then it will send a bus request. This is called bus request. Br is bus request. Okay, then bus request, also called hold request. Okay, also called a hold request. Then DMA controller is begging the access of control bus or system bus. Sorry, the system bus. Both, it may be address bus, data bus, or control bus. Okay, then CPU is not ideal. CPU is not never ideal. Okay, then CPU complete its work if CPU accessing the system bus. This is address bus, data bus, control bus, combinedly called system bus. Okay, if the CPU accessing the CPU bus, then it does it works, and and free the system bus, and give the controller to DMA controller. Then the DMA controller carries the data to IO devices, to the DMA buffer, then DMA buffer to main memory. And there is also a main memory buffer, also called IO buffer. Okay, IO buffer. Okay, data is stored in IO buffer. Then later, if CPU wants the data, then CPU will interact with this data. Okay, this is the simple concept. I would like to repeat it again. First of all, CPU give the command that there will be transfer between IO devices and main memory. Then the DMA controller send a bus request. Okay, then CPU free the system bus and give the DMA controller a bus acknowledgement that you can use the bus now. Then DMA controller can use the bus that time, and IO device from there also takes data transfer in between IO device and main memory, IO device to DMA controller, and DMA controller to main memory IO buffer. Okay, data transfer takes between IO devices to the DMA buffer, then DMA buffer to IO buffer in main memory. Okay, next move to what inside the DMA. Okay, it is the internal configuration of DMA controller, what inside the DMA controller. Okay, first of all you have to notice DMA address register. What is DMA address register? DMA address register hold the address of main memory. DMA address register hold the address of main memory. Okay, then then there is a DMA count register. Okay, what do you mean by DMA count register? You also know program counter. Okay, this is like a DMA count register is also like that. It count what count? It count the size of data which will be transferred in between IO devices and main memory. Okay, it count the size of data. Okay, if all the data is all the data is transferred, then it set to 0. Okay, uh, in the time when the data will be transferring, the CPU count register will be go for decreasing. Then at a time it will be 0. At the time the transfer will be completed. The DMA data register acts as a DMA buffer, hold the data temporarily in between memory and IO device. Okay, this is the DMA control register. Okay, DMA control register, it's very important. DMA controller register is very important. Okay, as you know, DMA controller register, it configure the DMA transfer, also program the DMA transfer. How it program? It holds I have already told you that there may be universal DMA controller for every IO devices. Maybe it's IO devices 1, or it's IO device 2, or maybe IO device 3. Okay, previously I told that there may be universal DMA controller for every device, or there may be dedicated DMA control unit for each devices. Okay, that's like DMA controller hold the hold the source and destination address. Okay, so hold the source and destination address of the data transfer, first of all. Then also hold the transfer size. Okay, also hold the nature of transferring. You can say, what is the nature of transfer? Okay, a nature of transfer means IO device is never one type of device. It may be a keyboard. Okay, it may be a keyboard or real-time device. It may be network devices, or it may be storage devices. Okay, it hold the behave of transfer. Okay, the type of transfer. It may be a network type. A network device is connected. Let's say Wi-Fi is connected. Okay, then it automatically read the data. And send to the computer, or send to the main memory. Okay, automatically. Or anytime, there may be real time system. Okay, there is a real time system connected. Maybe it collect the data, or the data will be transferred from the IO devices to the main memory. Okay, and also maybe there already a least priority data, and later there will be a high priority data came. So the low priority data will be overrated by the high priority data, and the high priority data may be transferred to the main memory. Okay, the DMA controller actually leads the DMA transfer. Okay, you have to uh, understand the DMA controllers works. It works very efficiently. It also hold the transfer address, like a data, like a source address or destination address, then transfer size, or then the behavior of the transfer, all this. Okay, this is all about DMA. And there is also types of DMA, like burst, or transparent, or cycle stealing. Okay, first of all, burst, then cycle stealing, then transparent. Okay, first of all, we'll discuss transparent. Okay, let's discuss burst. What do you mean by burst? Burst mean uh, DMA controller will be transfer a burst of data, or transfer the all data at a time, all data when it hold the system bus. If, let example, if our DMA controller hold the system bus, it will transfer all the data to memory. Then it will release the system bus. It will release the system bus after transferring all the data. Okay, this is brush transfer. Okay, then discuss about cycle stealing. Okay, there are clock cycles in our system. Then in DMA controller, in cycle stealing, DMA controller transfer for one clock cycle, then release the system bus, then CPU execute one more cycle, then give the DMA, then DMA again transfer for one clock cycle, then again give control to the CPU. That's like works DMA. Okay, in cycle stealing. Then there is transparent mode. What is transparent mode? When DMA controller feels the system bus is free, it will immediately transfer the data. It will immediately the transfer data. Okay. When DMA controller feel that the system bus is free, okay, let's transfer the data. This is called transparent. Okay. These are all about DMA controller. Okay. Thank you.